Hello and welcome to our virtual classroom seminar number 20. Move to Oracle Database 23 AI and everything you need to know about Oracle Multitenant. Today is part 2 of that seminar. We would like to tell you a lot about what to take care on, what to pay attention to, and how you smoothly can move into the multi-tenant architecture, which is the only architecture supported since Oracle Database 21c already. Now for today's seminar, let me introduce today's speakers. So first of all, myself, my name is Mike Dietrich. I'm product manager for database upgrades, migrations, and patching at Oracle. I work out from Germany, from the Munich area. And let me introduce the other speakers here. With me today is Daniel Oberby-Hansen. Daniel is also product manager for database upgrades, migrations, and patching, and focuses in our team a lot on AutoUpgrade, encryption, real application cluster patching, and many, many more topics. Daniel works out from Denmark, from the Copenhagen area. Then we have Rodrigo Schorsch. So Rodrigo also focuses on a lot of these topics, but in addition also on security. And Rodrigo also takes mainly care on our tools such as ORDIM and CMA, the Cloud Migration Advisor. Rodrigo works out from the beautiful place of Rio de Janeiro in Brazil. And with us today is also Alex, who is originally from Brazil, but now works in Texas from the Dallas area. And Alex focuses also on all types on migrations, but especially also on cloud migrations. We'd like to guide you today and tell you a lot more about multi-tenant. And before we do that, let me point you also to our blogs. So we all blog here. Alex blog, alexabala.com, Rodrigo's blog, dbarj.com.br, and Rodrigo blogs not only in Portuguese, but also in English, of course. And then Daniel's blog, dohdatabase.com, and my blog, mikedietrichde.com. On our blogs, we also share the slides, so you find the slides for download on Daniel's and my blog typically. And of course, we will make today's seminar also available for on-demand, typically a week after the session today. Now, if you need more virtual classroom seminars, then please go to mikedietrichde.com/videos. There you find all previous 19 virtual classroom seminars, and of course, also the slides. And whenever you click on one of the links, it gets you to our YouTube channel. And there below the video screen in the content section, you will find also like the links to all the individual topics. Because you see, some of the seminars are quite long, some of them are over 2 hours long, and you may not have time to watch the entire seminar, but you can also consume them, of course, in pieces. And we would also guide you to the previous one, because today is part 2 of everything you need to know about Oracle Multitenant. We did already part 1, and you find it on the blog as well. Now, let us start here. And before we start, we want to give you a big hug. Oracle DBAs run the world. And this is not just a marketing slogan. This is truth. Nothing would work without Oracle DBAs. So feel very much hugged from us. You're the best. You run the world. And we really, really appreciate that you tuned in today to our seminar. So from this year, let us start with the first topic and go directly into operations.
Thanks, Mike, for the introduction. So now let's talk about some multi-tenant operations like creating services, connect to the PDBs and CDBs. To connect to a PDB, you have some options. For example, if you are connected to the CDB using a common user with the right privileges, or if you are using sys or system, they also have this right privilege. You can do author session set container equals PDB name, and you can switch to this PDB. But for example, if you are planning to connect to a PDB using a local user, you have some options. When you create a pluggable database, for example, here we are creating a pluggable database blue, and you check the listener status, you can see there is a service registered on the listener using the same name as the PDB. And you can use this service name to connect directly to this PDB. For example, you can use the SQL Plus Easy Connect string using the username, the host name, and the service name. Or you can change the tnsnames.org file, add an alias pointing to this service name. We recommend you to try to keep the names of the PDBs unique on the host. And if it's possible, also keep this name unique on your entire environment. The multi-tenant option, you have a lot of features, and one of them you can use, for example, you can move a PDB from one CDB to another. And to avoid a service name collision, please try to have a unique PDB names across all the environment. According to the MMA guidelines, we recommend you to create your own service name and not use the default. If you have a simple environment, you can use the default, but we recommend to create your own service name. For example, you can connect to the PDB and use the package DBMS service to create the services and then start the service. If you are using Oracle Restart or you are using a RAC database, you can use srvctl to add the service and then start the service. And to connect using this new service, same thing, using Easy Connect, SQL Plus, username, host name, and the service name. Or you can add a new alias to your tnsnames.org file pointing to this new service name. To check the existing service name for your PDB, you can just query $services, and you see here, for example, the line number 1 is the default one when you create the pluggable database, and the second one is the created manually. What about the Oracle PDB seed? This is an environment variable. For example, you can set the Oracle seed to your instance and then set the Oracle PDB seed to your PDB. And when you connect directly to the PDB name. But this is only recommended if you are using an Oracle Business Suite database. If you don't have an ABS database, try to avoid this environment variable. It doesn't work on Windows, and we have some problems. For example, it produces no error. For example, the PDB is not started, or the PDB does not exist, or you mistype the PDB name, or the database is not starting normal mode. You end up connected to the root, and you don't get any error or warning message. What about toTask? This is another environment variable you can use, but it's just an alias to your TNS names entry. So for example, you set the toTask equal my alias. It's the same as you use the alias on your connect string. So now back to you, Mike.
So thank you, Alex. Now, as we discussed how to connect correctly to our containers, to our PDBs and such, let's go a step forward and check if we have to do anything with the scripts you execute, most likely on a regular basis, but also on-demand scripts in your environments. And first of all, let us keep an eye on something which is used quite usually. It's the cron tab. So on the cron tab here, we have a job which gets executed every hour. It's called important sh, so there's a shell script being called. And what is in that shell script? The shell script sets the environment with the Oracle SID and then uses the OS contacts to connect directly into our database. There's no password here. And then it executes some tasks. If you would do this now in a CDB environment, we would connect directly to the CDB $root, but obviously not into the PDB. So what do we need to do? First of all, you need to examine your scripts, and it doesn't just apply to such scripts. Please have also a closer look on your backup recovery scripts, for instance. What we add here is just a single line. We add an alter sessions at container equals red, and then we connect into the red pluggable database. Not too complicated, but you need to check that. The other alternative would be using a secure external password store. In this case, we can use an alias, and then it will use the password stored in the secure external password store and then connect directly. That's also a very smart way. Now, in order to execute scripts in a multi-tenant environment, there are several vehicles, I would call them. One of them, and the one we want to discuss here, is catcon.pl. but the others would be the scheduler, and the enterprise manager, of course, has a facility there as well. So let's keep a closer look at catcon.pl, because this is something we use by ourselves, and you'll see that when you execute certain things, but you will use it also by yourself. Typical example, for instance, is if you call datapatch, you will see that catcon.pl is used in the background or underneath the datapatch call. Now, when we look a bit closer, let's assume we have that important .sql, which does some tasks. How do we execute that now with catcon.pl? It's relatively straightforward. Keep in mind that catcon.pl is stored in RDBMS admin, so you either have to add the path or make sure you are in RDBMS admin, and be also aware that you should call the Oracle Perl and not any other Perl on the machine. And then you give a base name for the script called important, and you define here also the name of the container, and the PDB is a container as well. So this is why minus lowercase c, and so we connect into the PDB with the name red, and then we execute the important.sql. Now doing it with one, okay, fine, but the beauty of catcon.pl is we can pass a lot more options to it. For instance, we can pass on here the username and password if needed, and we can also pass on a longer list of PDBs. We have also the option with minus uppercase C to define that we use only the CDB dollar root, or we have our options, so please check the documentation for that. But in my case here, we use that script, important.sql, to run it in blue, red, green, yellow, purple, and orange PDBs. And we use 3 parallel workers for that. So in this case, since we have 6 PDBs, we will basically have just 2 cycles. And we should ideally also pass on that we want to have echo on. So minus E is echo on, and also a log file because we want to see the output. So at first sight, it looks a bit strange, but you will immediately recognize it's absolutely powerful what you can do here. And if you want to see more options of catcon.pl, please type in Perl catcon.pl -help. And then when you look at our scripts, you may have found already that there's a strange parameter, _Oracle script. And when you check our scripts in RDBMS admin, you find that we use that in 188 of the approximately 1000 scripts in RDBMS admin. So we use this parameter. And then you may go forward and check the documentation. And then you find out, wait a bit, that's not really documented in the Oracle documentation. Now we could say, hey, it's an underscore and we don't document underscores, but especially in this case, we need to tell you a little bit more about that because it's a very important underscore. By default, it's false. And there's a good reason why the default is false, but we set it to yes or to true if we use it. And then we leverage the capabilities of the _Oracle script. There's even a Moss note here saying, hey, you should not invoke that. And why you should not invoke it by yourself, we would like to show you a quick example. Let's create here a table as our app user, and then change afterwards the Oracle script variable to true and create another table. Both tables get easily created. You don't recognize any difference at first sight. But there is some very important difference. And this is when you check the Oracle maintain flag. So the Oracle maintain flag for our table T1 says no, absolutely fine. But as soon as you check in Oracle script and you set it to true, then it will check also the Oracle maintain flag and say yes. Even now at the moment, this may not cause trouble, but as soon as you execute patching scripts or do an upgrade later on, that may cause a lot of trouble. Because, for instance, in the upgrade, we have checks where we say, look, we do certain things only to objects in the database which have the Oracle maintain flag on yes. And trust me, we had customer cases where somebody just put Oracle script true in all scripts because it has the beauty that it executes things also in the PDB$seed. And the PDB$seed is read only by default, as we told you already. And with the Oracle script variable, you can execute things also in the PDB$seed. And so it was very convenient. But the point is, everything you do now, everything you create, every DDL checks then in the Oracle maintained flag. And this is something you, by all chances, must avoid, because this causes a lot of trouble later on. So don't use _Oracle script unless Oracle support tells you to use it. You could use it also to customize things in the PDB$seed. And also, again, this is something we don't recommend. There's no official note saying, please do this and that in the PDB$seed. We recommend either having your own PDB$seed with a different name, or use an afterburner script. So as soon as you create a new PDB, then make sure another script is executed doing all the changes you want to it. And do not use _Oracle script, or do not change it in the scripts unless Oracle support tells you. With this, I would like to hand over to Rodrigo to talk a little bit more about how to start PDBs.
Thank you, Mike. It's great to see that with just some little changes, we can easily adapt our scripts to this new multi-tenant environment. Now let's talk about auto-starting PDBs. So when you create a new pluggable database, you have to open it after you create it, and by default, it will not open the PDB when you bounce your CDB. If you want this PDB to automatically open every time you bounce your instance, or for example, after you restart your server, you need to save the state of the PDB. So you open it and you run alter pluggable database, the pluggable database name, save state clause at the end. And when you do that, you will save this open state in a view. The view is DBA PDB saved states. If you query this view, you will see all the PDBs that have saved states. If you don't do that, and for whatever reason your CDB needs to bounce, for example, after a server reboot, then all the PDBs will remain closed. So you have to manually open them every time. So we recommend you to save the state of the PDBs, especially in a single instance environment. However, if you are in an Oracle cluster, so if you have Oracle RAC or Oracle Restart, we recommend you to go another way. So you discard your saved states and you work with service. So why using services? Because with services, it's much better to organize where the PDBs will run over the nodes of your rack. So with this approach, you can use PDB subsetting. And with PDB subsetting, you can have some nodes running one given PDB and other nodes running another set of the PDBs. Let's see an example of this happening. So here, for example, we have a 3-node rack. And for example, in this 3-node rack, we have 3 different PDBs, the production one, the report one, and a development PDB. The production one is very important, and we want it to run across all the nodes of our rack. But for example, the report one is not that important. So maybe we can have this report one just running in 2 nodes of the rack and close it in one of the nodes. And for the development environment, for the dev PDB, we just need that running in one of the nodes. So if we organize this way, for example, having the dev one just running on the first node, the report one running on the second, third node, and the production one running across all the nodes, maybe we will save some resources that will make our production run faster because we have more resources for memory, for CPU, for the production database. So with PDB subsetting, you can organize this way and have your important PDBs running across all the nodes, but the less important ones just in some few nodes. How we implement that? With the service_ctl add service syntax. So here, if you don't provide anything, for example, for the production PDB, it will open by default across all the nodes of your rack. But when you give this preferred clause here to the add service command, you can specify in which of the nodes this specific PDB will run. So here in this example, we are saying that the report will just run on instance 2 and 3, while the dev one will just run in instance 1. Now let's talk about this containers clause. What is this containers clause? This containers clause allows you to run a given SQL statement across all the PDBs that you have in your container at the same time. So here, for example, we are running a select against DBA table spaces against all the PDBs we have in our CDB. And by the way, if you do a DBMS metadata on the CDB table spaces, you will see that the query is exactly like that. You have a select and many other columns from containers DBA table spaces. So when you run a select on CDB table spaces, it's simply running this containers clause for you. And how that works when you run with this containers clause, it will run that query against all opened PDBs. Here we don't see the PDB $seed, even though it's open, because exclude seed CDB view here is set to true. So we are excluding the PDB $seed from the result. But it will get the result for all the opened PDBs. So here we have PDB1, which is the root container, and PDB3, which is a user PDB. And optionally, you can filter out by the container ID, and then you would just get the result for a very specific PDB running this from the CDB $root. Okay, so here, for example, we are just getting the table spaces from our PDB number 3. And you can also use this containers clause for insert or updates. So from the CDB $root level, you can potentially insert or update a table in the PDB level. So here, for example, we are doing an insert into containers and then saying that we want to insert in these SH sales tables. And here, as I'm specifying con ID 7, I'm just inserting in this pluggable number 7, this row, which is from the country is Canada and the amount is 3,000. Now let's talk about security, one of my favorite topics. And imagine now you are a DBA administrator, you have a CDB, and you have many, many different PDBs on this CDB. Remember, we can have up to 4,000 PDBs in a container database. And now you want to give freedom for a user to use this PDB the way he wants, okay? So you will give DBA permissions on this PDB to this user, but you don't want to give all the possibilities for this user in this PDB, because a user which is admin in one of the PDBs can do a lot of stuff. For example, it can do network access with UTL HTTP or UTL TCP. It can create files on the OS level using UTL file. It can create partitioning. It can create a lot of stuff that may be against your options or against the policies you have related with licensing. So how do you restrict that? With PDB lockdown profiles. So with PDB lockdown profiles, you can restrict features, options, and even statements in a specific PDB. Let's see, for example, with features. With features, for example, you can block AWR, you can fully block network access. In this example here, we are disabling the feature network access. So if the user tries to use UTL TCP, UTL SMTP, UTL HTTP, or whatever other method to access the network from that PDB, it will be denied. You can also block fully, for example, the OS access. So if the user tries to create a new file on the operating system or to run an external procedure, for example, it will fail. And you can do much more restrictions with PDB lockdown profiles. You can also disable options. Let's say you don't have the partitioning license and you don't want your users on the PDB to accidentally use the partition option. So with that, you can disable fully the database partitioning option. You just say alter lockdown profile, disable option partitioning, and that's it. It will not be able to create any partition table or index inside that PDB. And finally, you can also block statements like alter pluggable database statements, alter systems, and many others. So here, for example, in this lockdown profile, we are fully blocking alter pluggable database statement, but the default table space clause. This one is the only one that has an exception here, and that we will accept on that PDB. So you see how easy it is to just create like lockdown profiles and limit the scope that this PDB can do in your environment. Here in this other example, we are fully blocking the alter system set clause, but the PL/SQL warnings and PL/SQL debug clause, these ones are accepted. So the user can still do some other alter systems, but with the set option, it will be restricted with just PL/SQL stuff, okay? How do you set up a PDB lockdown profile? First, you can set this, you create this lockdown profile on the root container, and you define the lockdown profile in this parameter PDB lockdown in the root. And by default, any new PDB and all the existing PDB will inherit this profile. However, you can still set the profile specifically in a PDB. And in that case, that specific PDB will just use this given profile. In this example is the very set profile one. Another thing that is very important for a PDB is to restrict where this PDB can create files in your OS layer. And when you create a pluggable database, when you give this path prefix clause, any file that this PDB tries to create or access on the OS level must be inside this directory. And I really mean any file. For example, data files, temporary files. If you try to use directories in your PDB, those directories must be created inside this path prefix. Or for example, even if you create a P file from SP file, the P file that you're creating must go inside this directory. And why that? To avoid that if an attacker has access to this PDB, that he will be able to touch in your Oracle files in the OS level. So he will be restricted to this path prefix. And potentially, you can also specify this PDB OS credential clause, because by default, any interaction that the database does with the operating system, it will do it with the Oracle OS user. But with this PDB OS credential, you can specify another user that has less privileges. So now it's with you, Daniel.
Thanks, Rodrigo. Now let me talk about noisy neighbors. But I'm not talking about the noisy neighbor, the young, hopeful musician living next door who practices with his heavy metal band at 2 in the morning. No, I am talking about noisy neighbors in your container database. That runaway PDB which grabs all the available resources so the other PDBs can't do anything. How can we avoid that? The most simple thing you can do is called instance caging, where we can set a hard limit of CPUs for each individual PDBs. Imagine you have a server with 8 CPUs. In the non-CDB world, you would slice the CPUs into pieces for each of the non-CDB databases. In total, you would use 7 CPUs, so you save some for the operating system. When you migrate to multi-tenant, you assign the sum of all the CPUs, 7 CPUs, to the container database by setting CPU count to 7. In our case, we have 3 PDBs. Now we want to do instance caging on each of the PDBs, so we define a hard limit below the CPU count of the container database. In our example, we set CPU count to 4 in each of the PDBs. So at peak interval, in one PDB, if it's super busy, it'll never use more than 4 CPUs, so we have some left for the other PDBs. Of course, the sum of CPU count in all the PDBs is greater than what we have in the container database. So if all the PDBs are active at the same time, they will fight over the resources, the CPU resources, but they will still get a fair share. But whatever happens, the container database will ensure that it'll use no more than 7 CPUs, regardless of what is defined in the PDBs. You can do something similar for shared memory, where you can define SGA target in each of your PDBs, and that'll act as a hard limit, and one PDB will not be able to go above the amount of shared memory. Again, going back to our example, in this case, we now have 8 gigabytes of memory. We leave some memory for the operating system, so we set SGA target as a limit for the container database. We use 7 gigabytes. In our PDBs, we define SGA target to 4 gig. So now one individual PDB is not allowed to use more than 4 gigabytes of shared memory. If all the PDBs are active at the same time, so the sum of SGA target in our PDBs that's greater than what we have in the CDB, if that's the case, then traditional cache management comes into play. For the buffer cache, there is a least recently used algorithm which will age out the oldest blocks. And for the shared pool, for instance, we have a different caching mechanism. If you want to use these features, you must have automatic shared memory management enabled for the container database, but that shouldn't be a problem because that is best practice anyway. If you want, you can still allocate a minimum amount of memory for certain shared pools inside a PDB. You might decide to use at least 500 megabytes or 2 gigabytes of memory for the buffer cache in one PDB. You can still do that even when you define SGA target as a hard limit. You can combine method 1, instance caging on CPUs, with the second option where we control the amount of shared memory. And for most customers, this will be enough to ensure that each PDB will still get a fair share of resources. But of course, it is Oracle database, so we can take it even further. We have more advanced features for you. The third method is to use Resource Manager in a more elaborate way, which is still very simple to implement. Instead of defining hard limits, which one PDB cannot go above, we will allocate minimum shares, and then everyone are allowed to use the resources that are free for all. Going back to our example where we had CPU count set to 7 in our container database, we can specify that one PDB must always have access to 2 CPUs, whereas the other PDBs just need access to 1 CPU. So we have 4 CPUs that are reserved, and the other 3 are free for all. Any PDB can grab those CPU resources. So if the first PDB is really active, it can actually use up to 5 CPUs. The 2 that are reserved, plus the other 3 which are free for all. And we can do something similar with shared memory. We had 7 gigs of shared memory assigned to the container database, and we can use SGA min size to define a minimum amount of shared memory, which is always available for a specific PDB. In this example, the second PDB has 1 gigabyte of shared memory reserved, and it can use the other 3 which are free for all. If you want to use these 2 parameters, it requires that you enable Resource Manager at root level. But it's super simple to do that. You just create an empty Resource Manager plan. Don't create any directives or consumer groups, just an empty plan, and you enable that plan in the root container. And we can make it even more advanced. If you want to enable the best possible sharing of resources in your database, instead of using minimum shares, you can create directives and consumer groups, which will enable the container database to share the resources in the most effective way. This was about Resource Manager on the container database level. But inside a PDB, you can still use Resource Manager to control resources between the users, just like you did in a non-CDB database. What about I/O? We just talked about CPU and memory, but what about I/O? Well, if you're using the Exadata database machine, we have the I/O Resource Manager, which is a really powerful tool that allows you to configure resource sharing even on I/O level, and you can very efficiently share resources between your databases. For other systems, it's really hard for the database to do effective I/O management because we don't know anything about the characteristics of the underlying storage system. So for source databases, you can only control the maximum amount of throughput and IOPS using two parameters. But it requires that the DBAs knows something about the underlying storage system. And if you move one PDB into a different container database on a new host, you probably need to adjust these parameters to the characteristics of the new storage system. So slightly more cumbersome unless you are on the Exadata database machine. Then, of course, on the same host, out of the same Oracle home, you can run multiple container databases. Just like you did with non-CDB, there are no changes there. If you have multiple container databases on the same host, you need to share resources between those container databases, just like you did in the non-CDB worlds. You would do instance caging on database level. So you set CPU count and you divide it between the different container databases. And you use SGA max size to slice the memory into pieces for each of the container databases. Again, for those of you on Exadata database machine or autonomous, in 23 AI, we have a new feature coming that allows a much better sharing of CPU resources between container databases. So some sort of inter-instance resource management. Underneath the hood, the databases will use Linux C groups to control the distribution of CPUs. But again, it's for Exadata database machine and autonomous coming in 23 AI. Now let me move on and talk about some of the things that the database does behind the scenes to keep your engine well oiled, the automated maintenance tasks. In your container database on root level, we have a maintenance window. By default, we have maintenance window every night, and in the weekend, we have a longer maintenance window. Actually, in the weekend, we have several smaller maintenance windows, but for simplicity, I'll illustrate it here as one big weekend maintenance window. In all the PDBs in your container database, we have a similar maintenance window, and by default, they start at the same time in the weekend, and they run until the same time at the end of the weekend. When the automated maintenance task starts, when the maintenance window opens, you will see that only two PDBs will run maintenance at the same time. The container database, in order not to deplete its resources, will ensure that only two PDBs are doing maintenance at the same time. If you want to allow more PDBs to run maintenance at the same time, there is a parameter that you can change. If we set it to 3 in our case, it means that now 3 PDBs, all PDBs in this case, can run the automatic maintenance at the same time. You just need to ensure that you have enough resources on your system. So if they all do gather stats on huge tables, it shouldn't deplete your system from resources. If you want to use your resources widely, if there is one PDB where you decide it doesn't really make any sense to do automatic maintenance, if it is a test database or a database that you scratch every day, why do you care about automatic maintenance there? You can simply disable automated maintenance. There's a parameter that you can change, and then the entire maintenance window will be shut for this PDB, and you can run maintenance in other PDBs instead. Another option you can do is to shift the maintenance window and adjust the duration to something that makes more sense in your organization. Coming back to the example, by default, we have the same maintenance window in all our containers. Well, we can move things around and we can find better times. We can change the window and the duration so we have a much better fit for our system. Another option is that you can go down in one specific PDB and selectively disable certain parts of the automated maintenance. Again, if we have a test database, do we really want to run the segment advisor or the evolve advisor? In some situations, it doesn't make any sense, so why not use the DBMS Autotask admin interface to disable it for such databases?
Thank you, Daniel. Now let's talk about Automatic Workload Repository, or AWR, in this multi-tenant world. Because before it was pretty easy, right? It was a non-CDB, and that was it. We could just take snapshots on that non-CDB. But now we have a CDB that can potentially have hundreds of PDBs. How does it work? Do we take one snapshot for everything? Do we have the snapshots for the CDB and also one for each PDB? Let's check that on the next slides. So the first thing here is that the database will automatically gather for you AWR data in both the CDB and the PDB level. So if you don't touch anything, it's already enabled by default. This is the default setting. There are two different levels of AWR data, the one that we take from the PDB and the one that we take from the CDB. Let's talk first about the PDB level. So if you create an AWR snapshot at the PDB level, it will only contain that specific PDB statistics, right? And also just some global statistics. We don't have all these global statistics here, just some of the global one. And the reason for that is because we don't want to expose for one single PDB what's happening across all the containers we have on that database. That's for privacy concerns and security reasons. Now, if you take a snapshot from the CDB level, here we will have aggregated PDB statistics plus all the global statistics. How do we take snapshots from the PDB or the CDB level? From the PDB, you need to connect on that PDB, and then you call the package DBMS workload repository. You run this procedure, create a snapshot. And the same for the CDB level, but now you do it connected on the CDB $root. You can also have different settings on the PDB and on the CDB level. So here, for example, we can have some specific properties at the CDB level and some other specific properties at the PDB level. The AWR data is always stored on the CSOTs table spaces. But when we have it taken on the PDB level, it's going to be on the CSOTs of the PDB. While when we take it from the CDB level, then it is stored on the CSOTs of our CDB $root. And the important thing to notice here is that when we take it from the PDB level, now if we unplug and plug this PDB elsewhere, we will move the AWR data with it. While when we take it from the CDB level, then it's going to be stored at the CDB $root. So if we unplug that PDB, we will not be taking the AWR data with it. So we will need to export it and then import on the PDB. By default, since 23AI, the collection of AWR data on the PDB level is enabled. This parameter since 21C was false by default, but starting on 23AI, by default, it's true. So if you want to disable the AWR collection on the PDB level because you already have it being collected at the CDB level, you can connect on a given PDB and change this parameter to false. And you can also use lockdown profiles, as I said on the previous section, to fully disable AWR access for one specific PDB. Now, imagine you're connected on a given pluggable database and you want to list all the snapshots you have for that PDB. There are three views that can give you this result. the AWR root snapshot, AWR PDB snapshot, and the class DBA hist snapshot. Let's check the difference between each of them. So first, the AWR root snapshot will show all the snapshots you have for that PDB, but that are collected on the CDB level. So someone run the DBMS workload repository .create snapshot procedure on the CDB level, and this took a snapshot for that CDB and all the PDBs. So running a select against this view AWR root snapshot will show you those snapshots that are stored in the CDB $root level. So here is an example. We connect on the CDB $root, and we call this procedure, which is gonna run on the CDB $root level and all the PDBs. Now, the AWR PDB snapshot is the opposite. It's only the snapshots that were taken on that specific PDB. So here, for example, if we connect on the PDB and we call this same procedure to create a snapshot, now we are creating the snapshot only for that PDB, and this will show only the snapshot that are stored on the PDB level. And finally, the DBA hist snapshot. This view will show you all the snapshots you have for that pluggable database, the ones that are stored in the CDB $root, as well as the ones that are stored on the PDB level. So if you simply query DBA hist snapshot, you get all the snapshots you have for that PDB on both layers. And here is an example. We have this con ID column in this view that can show you where this given snapshot is stored. Now it's with you, Alex.
As you have heard from Rodrigo, you can get AWR information from a PDB or for the entire CDB. Now, let's talk about patching. So, patching Oracle Home in a multi-tenant environment is same as for non-CDB. You can patch all at once. You can use Unplug and Plug, or you can use refresh local. So the database must be open, and only PDBs open will be patched. You don't need to open the database in AutoUpgrade mode or use restricted session. And you can see what's happening behind the scenes checking the data patch log. So if you have too many PDBs and a lot of CPUs, you may be seeing some contention. So in this case, we recommend you to check the process parameter. Data patch will always patch CDB root and PDB seed automatically. And data patch always patch CDB root first. In this case, you can see the PDB tree is not open, so the data patch will skip this PDB. And data patch determines parallel degree based on the CPU count. You can speed the patching process using the AutoUpgrade if you are using multi-tenant and rack. For example, you don't need to patch everything on node 1. You can distribute between the nodes. So to do this, just change this parameter on your configuration file. Now, back to you, Daniel.
Thank you, Alex. I really love distributed patching. It is such a cool feature. But I'm a greedy guy, and I want more. I want even faster patching. What do? Well, the next thing I could look at is components, because simply speaking, fewer components in your database means faster patching. And from experience, I know that the Java VM and the spatial data option are those components that normally takes the longest time to patch and upgrade. Also ORDIM, which is the multimedia components, it's desupported in 19C, but underneath the hood, we still keep it around. Those components typically take the longest time. Of course, they are cool components. If you're using that functionality, well, you got to keep them in your database, and that's the price that you have to pay. If those components are in your database, well, just because they are in there, well, see if you can remove them. From experience, we know that it's easier to start with some of the components and see if you can remove those. We find it easiest to start with Workspace Manager moving to Oracle Text. If you can remove those, that's fairly easy. But some components have a dependency between the other. So if you want to get rid of label security in your database, well, then you also must remove data vault. And there are other sets of components that has a dependency between each other. But you can use this overview to get an idea of which components to start with. If you are on 19.16 and you are using container databases and you have PDBs with a different set of components, well, then you might see that patching seems to take quite a while. And that's because we identified an issue in datapatch. If you have multiple PDBs with a different set of components, then datapatch cannot process those PDBs in parallel. We have to work with one PDB at a time and then make our way through sequentially. And of course, with many PDBs, that takes forever. So in 19.16, we came out with a new version of datapatch, which, despite the set of components in your PDB, can still do full parallel when we are patching your database. But of course, this only applies to you if you're on 1950 or earlier. Beyond that, it's already fixed. But if you are on 1915 or earlier, you really need to patch your database. You are too far behind. Thank you. Speaking about data patch, what happens if one of the PDB fails? In this case, PDB 3 fails for whatever reason when we run data patch. What happens? Well, the next time you restart the PDB, you will see that the PDB with a failed patch will start up in restricted mode. It's still open read-write, seems good, but it is in restricted mode, so we effectively do have an outage, because now only sysdba can connect to the database. Of course, that is of no use. The container database, by default, will restart a PDB in restricted mode if you forgot to run data patch or if there was an error during data patch. If you want to change that behavior, there is an underscore parameter. Of course, this wouldn't be a good webinar if we didn't have a fair share of underscore parameters to share with you, and this is one of them. PDB data patch violation restricted, you can set it to false. If you do that, the next time the PDB fails, it'll start in read-write mode and unrestricted, even if you forgot to run data patch on that PDB or if there was a patching error. But that doesn't mean that everything is fine. There is still a patching situation that you need to attend to, either by running data patch or by fixing the issue in your PDB and then run data patch. That was enough about patching in multi-tenant. It's very similar to non-CDB after all. So now I'll hand you over to the capable hands of Rodrigo, who will talk about upgrades.
Thank you, Daniel. Now let's talk about one of my favorite topics, upgrading an Oracle database. So in the multi-tenant architecture, there are two approaches that you can go with the upgrade. You can either upgrade just one single PDB, which we call PDB upgrade, or you can upgrade the full stack, the CDB and all the PDBs that you have. So this is the CDB upgrade. With the PDB upgrade, first you need to already have a CDB in the higher release that you are upgrading to. So here in this approach, if it's a non-CDB, what you do is you get that non-CDB, you plug it as a PDB, then you trigger the upgrade and the conversion actions. While if it's already a multi-tenant database, you simply unplug, plug, and upgrade. And here it's all automated for you using AutoUpgrade, as we are gonna see later on the slides. Now, in the CDB upgrade approach, it's different. You trigger the upgrade action on the CDB, and it will upgrade this first the CDB dollar root, then all the pluggable databases you have plug them on that CDB. Which upgrade approach is the best one? And as always in the IT world, it depends. PDB upgrade has some pros. For example, it's flexible because you can do one PDB at a time. It's fast because you don't need to upgrade first the CDB dollar root, which usually takes some time. And also you have full control in which PDBs you are upgrading. However, there are some cons. For example, you cannot use flashback database to go back if you have any problem. While the CDB upgrade also has its pros. For example, it's less work because it's more automation. It's all in one, right? It's the upgrade main as one principle. Also, everything happens in place. And you can, of course, use the flashback database protection. So those are the pros. So you have to decide which strategy fits best your environment. Here are some AutoUpgrade config file examples. First, for the PDB upgrade, if you are going from non-CDB to a PDB, all you have to specify is your source SID, so the source non-CDB database, and the target CDB that this non-CDB will be plugged in, upgraded, and converted. And if it's an unplug-plug operation, so if your source is already in the multi-tenant architecture, then all you need to do is specify the same parameters, but now you need to add the PDBs to tell which PDBs on that multi-tenant you want to move to this higher release. And here is an example for the CDB upgrade, which is even more simple. All we have is to specify the source home, the target home, and the source SID. And all will happen in place, so the SID later when you connect will already be on the higher release. You can also control the parallelism of your PDB upgrades specifying this catctl option parameter in your AutoUpgrade config file. So this -n 4, for example here, will tell that you want 4 parallel processes per PDB. Let's see an example of an upgrade happening for one of our lab databases. First, we open this PDB1 config file, and we can see here our source database, CDB 12102, our target database, CDB2, and the list of the PDBs that we are unplugging and plugging, only the PDB1. So basically what we are doing here is taking this PDB1 out from this 12102 database and plugging in into this 19C database, CDB2. So first, let's start with the analyze mode. We run AutoUpgrade, and we wait a while until the analyze mode finishes. And finally, when it's done, we can see here the status.log file at the end. If we open this file to check the status, we can list what is the versions before and after the upgrade. And also we have the list of log directory and details. And we see pre-chat passing and no manual intervention needed. So we can move forward with the deploy mode. So we run the deploy mode, list jobs to list all the jobs we have. And here the job is still 0%. We can do this status manage job to get more details about the job, like all the stages and the timings, and also all the log locations. And we can see that it's still at 6%. And after some time, the upgrade finishes. Now let's connect back on our CDB. And now if I list the containers that I have, I see that the PDB1 now is on this CDB2. So it was moved from the 12102 to this 19C database. So in the demo that we saw, we were just moving one PDB, but we can upgrade several PDBs at the same time using AutoUpgrade. We just need to give them as a comma separate list to this PDBs parameter. You can optionally also rename a PDB while you are unplugging and plugging, so you can plug it already with a new name. And by default, AutoUpgrade will do a no copy operation, so it's gonna reuse your data files, but you can also specify the started PDB copy option to convert and copy your data files while you are unplugging and plugging this PDB. AutoUpgrade will always start first with the CDB $root upgrade. So first we upgrade the root and then all the PDBs in parallel. The number of processes or worker processes that we have, we can control via this catctl option parameter with the minus lower end now. Okay, by default it's 4, but you can give any number here. So for example, if I say 8, now I will have 8 processes to handle my upgrade with Parallelism. And also you can specify how many workers you will have per PDB. This is the upper end that I already showed on the slide before. So this upper end, for example, here 2 means that each PDB will have 2 worker processes to handle the upgrade. And doing some maths here, if you get the total number of processes and divide by the number of the processes that you asked to have for each of the PDB, you have how many PDBs you will upgrade simultaneously in parallel. So for example, if you have 16 processes and you want 4 processes per PDB, 16 divided by 4 is 4. So you have 4 PDBs being upgraded simultaneously, okay? Single tenant upgrades will always take longer. And why? Because to upgrade that single PDB, you first need to upgrade the CDB $root, and then you're going to upgrade that single PDB together with the PDB $SID. So you can scale the process by upgrading more PDBs simultaneously. Let's see some benchmarks now about the upgrading process with Mike.
So thanks, Rodrigo. Now, we all saw how important CPU power is when we upgrade a multi-tenant environment, let us discuss or show you a benchmark we did a while ago. So in this case, we upgraded a container database environment from 12.102 to 19c. We did it in the Oracle Cloud. We had lots of memory available, so there was no constraint. We created 52 PDBs in a container database environment, and we created the PDBs just as a standard set with all components in it, which in this case were 17 components. So they exist in the CDB $root and in all the pluggable databases. 32 CPU count, SGA target 80 gigs, PGA aggregate target 20 gig, and let's see what we get. So at first, with the first run, no treatments at all, the upgrade of the entire environment took a bit over 4 hours, as you can see in the graph. But what you see also in the graph is that there's a very mixed load in the system, and we only in very rare cases, we go really until the potential saturation of the system. So ideally, we would be like constantly at 90%, which we are clearly not. So there's a lot of room for improvement, I would say. So what did we do first? First of all, we saved some time. And you can save easily time by gathering sys, system, and fixed object statistics beforehand. If you don't do it, AutoUpgrade will check, and if your stats are older than 8 days, AutoUpgrade will regather them. Do this upfront, 24 hours before, then all should be fine. In this environment here, it saved us 12 minutes, which is not bad. Then when we look at the upgrade of the CDB $root, in this case, we have lots of bandwidth, but of course we upgrade only one container, the root container this time. The database, as you saw from Rodrigo before, assigns automatically, in this case, 8 parallel workers. And trust us, with more workers, there wouldn't be more or faster progress or whatever. At some point, you get so much contention that a maximum is really 8 workers we want to use. Now, how could we optimize that and get the CDB $root upgrade to progress faster? We thought about removing components. So this is an artificial test at this case because we remove components only from the CDB $root. But if we do so, then we speed up the upgrade of the CDB $root by 13 minutes. Not bad. But let's do this and go a step forward. If we focus on the PDB $seed and the 52 PDBs. By definition, as Rodrigo explained before, with the CPU count being 32 and 2 workers per PDB assigned, we would get 16 PDBs to be upgraded in parallel. What if we overload that? So we increase the number of parallel processes. We tell our system, hey, let's put a little bit more power on it. We have CPUs, but let's leverage them a bit more and increase the number of overall parallelity and having more PDBs upgraded. We still stay with the 2 workers because that has been proven ideal, but we want to have more PDBs upgraded in parallel. So we changed this now to 54 parallel processes. So you see here the cutctl options minus N54, and this sped up the PDB upgrade by 26 minutes. That's good. So a step forward and remove now also the unused components in the PDBs. So we basically went on with the same exercise we did for CDB $root before and removed the unused components. And this really added a lot of speed because we have so many PDBs. So in this case, we are now 48 minutes faster for this part. And finally, for the post-upgrade part, recompilation and other tasks, there's not much we can do. This is already, you see it, very high load on a system in a very short amount of time. This is highly optimized already. What you could do is you could potentially skip the time zone upgrade, and we'll talk about this a little bit more in detail later in this seminar. So in a summary, what did we do? Gave us statistics, gave us a 5% improvement. Not too much, but something you could easily do and you should do if no automatic job is doing that all the time for you anyway. Then removing unused components from root and the PDBs, this saved us 19% of the overall time. That is a significant impact. Increasing the number of parallel PDB upgrades gave us another 10%. And overall, if we summarize all this together, we are 32% faster if we combine all these tasks. So there is some improvements possible. At the end, we were under 3 hours, where we started with over 4 hours for the upgrade, which is a significant speed increase, actually. A few things since I touched the component topic already, and Daniel showed it before in relation to patching. As we explained already in the first seminar, the CDB $root you're plugging in either with a non-CDB or with a PDB must have a superset of components installed, so same or more components. If you don't have that, there will be a plugin violation. And a plugin violation means the PDB does not open unrestricted. So you need to fix that. It's better to do the right things before. And there are, in this case here, in my example, my non-CDB has spatial data option and label security, but my PDB has the JVM, the Java Virtual Machine component installed. And then I should make sure that the CDB $root I provision has all these components. When you miss one, easy deal, open the DBCA, the configuration assistant, and just click on the right component, say maintain or configure a database, and then add the component. It will do the right steps for you. So do it even if you have PDBs already in it. It does the right thing. But there are special cases with 23 AI upgrades and migrations. And the special case here, the first one is multimedia, the ORDIM component. ORDIM actually, when you remember some of our earlier seminars a long while ago, we said, hey, with 19C, ORDIM is like desupported, and we remove ORDIM from the database, but the component still stayed in DB registry, and it wasn't completely removed from the database. So what you should check, if you do it manually, and trust us, AutoUpgrade does this check for you if you use AutoUpgrade, check if the user mdsys exists in your database. mdsys is the user used by spatial data option, but even if you don't have the spatial data option installed, but ORDIM is present, you may have the mdsys user. So as soon as mdsys is present and SDO, spatial data option, isn't present, that means you must install spatial data option in the root container of the container database you're going to plug into. If you don't do that, then there will be some treatments to ORDIM, but you basically have a plugin violation and the PDB will not open unrestricted until you install SDO. So try to avoid that situation. If you see ORDIM, pay close attention to the warnings in AutoUpgrade. They tell you what you need to do then and follow these instructions. Something similar happens with the Locator. The Locator was basically a stripped down, non-licensable option of lightweight spatial data option. In the older days, spatial data option was an extra licensable option, and in order to give you some of geospatial functionality, the Locator got introduced. In 21C, the Locator even became its own component, so you found it in DBA registry or CDB registry. Now there's a special treatment because with 23AI, the Locator completely disappears. It will be moved automatically into SDO, spatial data option, because SDO is license-free for a longer while already. So there's no Locator needed anymore, and it will be transformed automatically. The challenge is to make sure in these cases that you have spatial data option again installed in the CDB root you are going to plug into. AutoUpgrade again will give you the right warnings, but be aware that you should have SDO provisioned in your receiving CDB root. Otherwise, you'll be in trouble afterwards. Or another option is if you say, I don't need Locator, I don't need ORDIM, and I don't want SDO, even though it's extremely powerful, then remove it. But remove the Locator and ORDIM beforehand, before you plug in or before you jump over to the new environment. Make sure those are safely removed. So do a check in your source on the DBA or CDB registry for the comp IDs ORDIM and LCTR. LCTR, as I said, exists only in 21C. And then on the blog or in the documentation on MOS, you find ways to remove it safely. And this is the situation where you can avoid installing SDO in the receiving CDB root. So either way is fine. You need to decide. AutoUpgrade gives you the right warning. And sometimes when you remove components like we do here, you have some invalid objects afterwards and you should recompile. Now recompilation, I think you all know the classic script utlrp, recompile, and this exists everywhere and since ages in the database. But we always had also a subscript of it called utlprp, parallel recompile, which allowed to pass on a parameter. utlrp went per of CPU count, and with utlprp, we could basically fine-tune that if needed. Now with 23AI, we introduce a new script called utlprp-om for parallel recompile Oracle maintained. So this is for Oracle maintained objects only, because the downsides of the other scripts is they try to recompile everything. And if you do this in a development environment where people create and drop a lot of things and don't take care that much on like cleaning up stuff, you have the recompilation often running for like a long time. So in this case, we only go for Oracle maintained objects. And this is by default in RDBMS admin from 23AI on. But if you use AutoUpgrade, a newer version of AutoUpgrade, it brings that script already in 19C and in 21C. And as part of the AutoUpgrade jar file, it unpacks it and uses that also to recompile only the Oracle maintained objects. What do you do? And here we have our friend catcon.pl coming into play again. We say catcon.pl -b, this is the base name of the log files, into the temp directory, 10 parallel workers, and we call utlprp-om with 16 parallel threads. So you do this way, as shown on the slide here in red, -p16, and then you have 16 parallel threads and 10 workers. So this is quite helpful. And with this, I would like to hand over now to Daniel to show you a very special new technology to upgrade databases, basically on a click of a button. Daniel, you go on, please.
Thanks, Mike. Now I have the pleasure of talking about one of those new shiny features in 23 AI. It's called replay upgrades. This is a feature that enables you to upgrade a single PDB faster. But it's actually not a new feature in 23 AI because we snuck it into 21C already. But since most of you will skip that release, you will come across this for the first time in 23 AI. And to be honest, we've had it in Autonomous Database since 18C, so it's not a new feature anymore, but it's still shiny and cool. For you as a user, you will notice replay upgrade for the first time in 23 AI when you plug in a lower release PDB and you open it. You will see that the open command takes minutes and minutes to complete. You might think, what on earth is going on? Why is the database so slow? Why does it take so long to open my PDB? Well, there's a good reason, because underneath the hood, the database is working like crazy to upgrade the PDB. And when it finally completes, you don't need to upgrade it because the database did that for you automatically. If you look in database properties, you'll see there is a new property called upgrade PDB on open. It defaults to true. This controls replay upgrade. It's on by default. So when you plug in a lower release PDB, the upgrade happens automatically as soon as you open it in normal mode. If you open the PDB in upgrade mode, then replay upgrade doesn't kick in, only when you open in normal mode. And you might also see there's a new property called convert non-CDB on open, because we can use the same functionality to convert a non-CDB database to a PDB. You don't need to run the non-CDB to PDB script anymore. The database can do that for you. So you can take a 19C non-CDB, you can plug it into 23 AI, and when you open it, the database does the majority of the work for you. Simple and easy. So what is this new trickery in replay upgrade? How does it work? To illustrate that, let's take a step back and look at traditional upgrade. A traditional upgrade consists of a number of phases. In each of the phases, we have a number of scripts that we must execute. And if we take a deeper look into one of those scripts, it can contain, for instance, PL SQL. In the example here, well, we do something differently depending on whether Java VM is installed. We might also do something differently depending on the source version you come from. And then can be all sorts of code which makes the upgrade adjusted to your specific database. But in the end, in one of the scripts, you will find DDL, changes to the data dictionary. In this case, we have a create table and a create index. And with replay upgrade, we capture those statements and we store them in a long list of DDL statements that we need to execute for this specific upgrade in this specific container database. With replay upgrades, we only execute what we have found out is necessary for this database, whereas traditional upgrade, we will investigate your database, we will make choices along the way to determine what do we need to do for your database. Replay upgrade is usually the faster approach. Traditional upgrade is the safer approach. If you want to get some more details, you can take a peek into the data dictionary. There's a table called PDB_sync$, which has a list of all the commands that has been captured, which will be replayed automatically when you plug in the next PDB. So traditional upgrade, that is a safer approach. It's more customizable, so that's why we prefer to use it in AutoUpgrade. Whereas replay upgrade, if you just open the database manually, then it'll kick in and do the work for you. With replay upgrade, we only execute the commands we have captured. whereas traditional upgrade relies on catalog and catproc and will need to do a lot of create or replace statements, which might change something, or, well, it depends on your database. We did a comparison between replay upgrade and traditional upgrade to see what was the benefit of using replay upgrade. The best example was coming from 18 to 19. Those releases are really close to each other, so there are not that many changes captured by replay upgrade. And in this case, we could see that almost 75% of the statements were actually not needed when we did replay upgrade. So there was a big benefit in that case. After a PDB has been upgraded with replay upgrade, you still need to run datapatch so we can bring in the very last changes from the patches. And there are also post-upgrade tasks that you should do, like gathering dictionary statistics and so forth. You can look in the documentation for the complete list of recommendations. But if you use AutoUpgrade, of course, then we do all that work for you. If something happens with replay upgrades, well, it's not a black box. You can still see what actually went wrong. You can query the new view DBA app errors, which will have some details. You can also look in the alert log, and there will be dedicated trace files in the trace directory coming from the replay upgrade engine. If something happens during replay upgrade, you can revert to traditional upgrade, and chances are traditional upgrade might be able to find a way through where we can actually upgrade the database. Otherwise, you need to engage with support and solve your specific issue. There are ways where you can enable or disable upgrade on open or replay upgrade. There's an alter database upgrade command, or you can change the properties in your database also if you want to disable the automatic conversion of non-CDB to PDB. Of course, we all love performance features. We all love when things go even faster. So I'm pretty sure that Mike has a few more tricks up his sleeve. Take it away, Mike.
Thank you, Daniel. Now we can discuss a few performance features. The ideas make your upgrade run faster. The first one is not new in 23 AI. It's called proactive fixups. And the idea is faster upgrades when you have many PDBs. In order to use proactive fixups, you have to set this parameter in the AutoUpgrade config file. So you have to use tune setting equals proactive fixups equals true. What we can do then with this performance feature, we can combine certain stages on a PDB level. So we don't do it in like, now we wait for all PDBs to finish the upgrade and then we enter the stages afterwards. Instead, once a PDB is upgraded, we can enter on a per PDB basis the stages afterwards. So this isolates also errors within PDBs. And of course, that feature works for CDB upgrades only. So when we look at the classic flow, we start with a guaranteed restore point, we enter pre-upgrade, pre-checks, pre-fixups. Then we do DB upgrade first for the root container, then for the PDBs in parallel. Once this is done, we enter the post checks, the post fixups, and then post upgrade. Now, what is different with the proactive fixups? At first, we start, of course, with the pre-fixups. And once those are completed in the CDB environment, we take care on the root container first. So for the root container, we do DB upgrade, post checks, and post fixups. But as soon as the root container has gone through these stages, we repeat those now in parallel for the PDBs. But we don't wait for all the PDBs being upgraded. We do DB upgrade, post checks, and post fixups on an individual per PDB basis. And so ideally, we avoid also contention and then can come quicker to the post upgrade phase for the entire environment. Of course, you won't feel that with a single tenant. You will feel this when you have really a lot of PDBs. In the output on AutoUpgrade on the console, you see here the difference. So instead of having all of them now in DB upgrade mode and waiting for the last one to be upgraded, we have some PDBs which entered already post fix-up stages. And also when we do this now in a real world test, so here we have just 4 PDBs in the root container and 4 cores in the system, so not a very powerful system. So this test upgrade took 180 minutes. But when you look at the post fix-up stages here, we see that we save over half an hour there, and overall the entire upgrade is about 50 minutes faster than before. And when we have now even more PDBs, now we repeat the same test on the same box with a little bit more CPUs added. So we have 16 PDBs, we have root container and all the defaults. And again, when we compare this phase here, we save 45 minutes. So the entire upgrade again is over an hour faster than it was before. So this is the idea when you have many PDBs, and it counts even more the more PDBs you have. So the more PDBs, the greater the benefit. Proactive fix-ups also isolate each PDB, so an error in a given PDB don't affect others. What does that mean? Let us have a closer look here. So this is the default. We have a problem, upgrade issue in PDB number 3 here. So an error in a PDB upgrade halts now the entire job. And the job can't be complete, so the upgrade will stop. When we have proactive fix-ups enabled, and we have now an error in that same PDB, then all the others will complete and only this PDB won't complete. So the entire job completes except for the upgrade in this single PDB. So we isolate also the errors, which is a really good side effect of that feature. Of course, a restore point protects you only on a CDB level. So keep that in mind. You can only flashback in such cases the entire CDB. So it's better to solve that problem afterwards for an individual PDB if that happens. Now, I told you already that we can start with these phases when a PDB becomes available. So in addition, by default, what we have is we start with the phases afterwards only when all PDBs are upgraded. This is the default, and the parameter treating that in the AutoUpgrade config file is called max PDBs available. Default is false. But you can turn this parameter to true, and this then switches to immediate availability. So this immediate availability will now make PDB1 already available when the upgrade has been completed. The same happens then as soon as PDB2 is available, and then also sessions or applications can connect to it. And same, of course, for PDB3 and PDB4. If you want now to control the order, because you saw 1, 2, 3, 4, then make sure, first of all, that all PDBs are specified. That is very, very important. So here's an example. In the prefix, name the PDBs, and then set priorities. So set a priority here for sales prod. We set priority 1, sales dev priority 2, sales UAT also priority 2, and sales test is the least important one. It can go lost. We want sales prod to become available at first. And by the way, this setting also applies when you use AutoUpgrade for patching. Then if something goes wrong, so we have set this now to true, what happens if we have an error here in the PDB number 4? So if that crashes or has a typical issue, can we flashback the entire CDB? No, we can't. Or, I mean, you can, but typically you don't want to have that because all the other PDBs have been available already, and maybe the applications have been connected. So be prepared if you do that, that you solve the situation now. And with that, I would like to hand over now to Alex.
Thanks, Mike. Let's now talk about distributed upgrades. So distributed upgrades use all nodes in a cluster, resulting in a faster upgrades of the CDBs. It applies to rack only and requires proactive fix-ups. So how does this work? You can distribute the upgrades between the nodes. It's a performance feature. It validates for CDB upgrades on rack only. First, CDB root will be upgraded on the local node, setting the cluster database to false. Then AutoUpgrade will upgrade all the other PDBs using the other nodes, setting the cluster database to true. So how it works? Node 1 here, cluster database equals false, so all the PDBs will be upgraded on only one node. If you want to use the other node, so you can use this option and distribute the PDB upgrades. To check the status, you can check the AutoUpgrade log console and see what's going on. To enable distribute upgrade, it's very simple. You just need to change this parameter to true on your AutoUpgrade config file. Now, back to you, Mike.
Thank you, Alex. Let us go into the final topic for today, time zone upgrade. And there's a promise which was given in Oracle Database 21c, which was called near zero downtime time zone upgrade. So first of all, since Oracle Database 1918, since this RU, we ship all available time zone files. So you find them in Oracle Home or Core Zone Info, but only for the long-term support releases. That means when you look for them in Oracle Database 21c, you still have to install them via separate patches manually. But in 1918 and forward, we ship them automatically, and we will do the same thing with Oracle Database 23 AI. Now, in order to check the current time zone version in a multi-tenant environment, you connect to the root container, and then it's very important that you set this parameter we recommended in the multi-tenant part 1 seminar already, the exclude seed CDB view to false, because otherwise you miss the setting in the PDB $seed. Then we check here on sysprops $ with a container query, and then we see in this environment we have in all our containers, container ID 1 is CDB $root, container ID 2 is PDB $seed, and 1 PDB here. We have everywhere time zone version 32. Now in AutoUpgrade, when you would like to add the time zone change, you have to set time zone underscore UPG yes. Or to be more precise, if you want that, you don't have to do anything because the default is the time zone change for database upgrade. Not for patching, but for database upgrade, default is yes. So if you want to avoid the time zone change as part of an upgrade, then you have to set this parameter explicitly to no. In case AutoUpgrade finds a divergence between the time zone version on the source higher than on the target, it is pretty smart and copies the necessary files over to the target Oracle Home. When you do a multi-tenant time zone upgrade, then make sure all PDBs are open unrestricted, and also make sure that PDBs start automatically. So as we explained before, either save state is your savior here, or in a RUC environment, make sure you have the resources defined correctly. Why is that? There's a restart happening. So what will happen is when the CDB $root is finished with the time zone upgrade, then a restart will happen with the standard scripts. And once this restart happens and your PDBs are not coming back online, then the time zone change will fail afterwards. So be really aware of that. The scripts we deliver work now very well with multi-tenant. So the UTLT set UPG check script and then the apply script. So you can use them one after another. There are no special tasks needed anymore as it was in previous releases. And then, as I said, there was this promise with Oracle Database 21c that we have a near zero downtime time zone upgrade. First of all, if you want to use the script in 23, then please make sure you are at least on 23.4, because otherwise the scripts I showed you on this previous slide will not work, neither in 21c nor in 23 AI with the near zero downtime technique. Now, how does that work and what does it do, and is it really near zero downtime? First of all, there's a new parameter we introduced in 21. It's time zone version upgrade online equals true. By default, it's false. So you have to turn this parameter on purpose to true. And when you do now a time zone upgrade, then there's no startup upgrade necessary anymore. Where's the difference to before? Before there were two restarts. The first restart started the database in upgrade mode. Then the time zone for the system data or for the data dictionary got changed. And once this was done and completed, Then the database got restarted in regular mode, but there was again another restart, and then you could adjust the user data. Now this startup upgrade is not happening anymore. It's not necessary. So this is good news actually. And then you decide when you want to restart your database. So you use this parameter, you do a time zone change, and then you decide when you want to restart. So there will be a change in the dictionary, but it will use sort of a mixed mode. That means some data will be still kept in the old time zone, and when you insert now or update data, it will use the new time zone setting. The downside may be that there's a conversion, and right now we can't tell you what the effect of that will be performance-wise, but there will be a conversion needed as long as you operate a database in this mixed mode. So my recommendation would be to do this restart as quickly as possible to avoid any performance impact, but you decide when you want to restart. Now, when the user data gets adjusted, there's one thing you have to be really aware of. We try to do this now online. So before that, there were locks on the objects and it was an offline operation. Now it's an online operation. We use online move, but we don't check. What does that mean? There's no check for space availability. So if you have now a 10 terabyte table and it has a column with timestamp using time zone and it needs a rework because you do the time zone upgrade, then that feature will try to create a complete online move, which means an online copy of that table, and you may not have 10 terabyte available. This is why we think that feature needs a little bit of improvements over time, but give it a try. If you want to learn more, there's a link to a blog post telling you more about that. With that, I think we've made it, and I hand over to Daniel for the wrap for today.
Whoa, that was a lot of information, but you made it all the way to the end. In the previous webinar, part 1, we talked about migration to multi-tenant. In this webinar today, part 2, we covered some operational stuff, patching and upgrading on the multi-tenant architecture. We spent hours talking about multi-tenant, but really, we just scratched the surface. There are so many other things to explore in the multi-tenant architecture. There are so many new features and functionality that can bring benefit to your organization, that can make you more successful with your data and bring benefit to your organization. If you want more tech stuff, you can subscribe to our YouTube channel, and I promise you, from the bottom of my heart, it's all safe to subscribe to our channel. It's all tech, no marketing. We post videos every week. Scan the QR code so you don't miss out on anything. The entire team would like to thank you for joining this webinar today. Thank you for attending and learning about multi-tenant. For now, the entire team is super busy preparing for CloudWorld coming up in September in Las Vegas. And we are working very hard to make this CloudWorld the best CloudWorld ever. This also means that there will be no new webinar until the end of the year. So be sure to subscribe to our blogs so you don't miss out on the next webinar. Until we meet again in Las Vegas, thank you so much and have a nice day.
database to the next level. Upgrade that Oracle. Feeling like a rebel oracle. Twitty we on the rise. Multitenant CDB, open up your eyes. Now we on the move like never before. Upgrade in the database, gonna explore. Cool features flowing like a river so wide. Gonna make that PDB sing worldwide. From the humble start to the top we go. Higher, faster, stronger, don't you know? Oracle database, you're my number one. With that Multitenant CDB, we've just begun.